Hi, my name is Jonathan Terrell. This is for FTT 122-25005-CB8 56255. Introduction to Ammunitions and Basic Ballistics. This is week 6. Week 6 here we got 7 topics. First one is trajectory and sights. So I'll use this tube. PVC tube, it's a sight, and snap cap is trajectory. So your sight will be a straight line, but the trajectory is at an arc. Some say that the point to where you aim should be at the 36. I think it should be 50 because 100 and 200 will be pretty close. Alright, the next one is gyroscopic drift. The bullet leaves at an angle and it spins to the right or the left, but usually the right, and it will cause it to veer off to the right or the left, just depending on the angle that it's spinning. If you didn't have the spin to stabilize it, the air pressure would cause it to tumble. Alright, the next one is drag, and you got the bullet speed, and increase bullet speed means that you got more drag. Drag is gravity, wind, earth rotation all affects that. Air pressure as well. Ballistic coefficient. High ballistic coefficient means more aerodynamic. This would definitely be more aerodynamic than that. And the wind will push the bullet or projectile off course. Let's see here. So I believe this is part of the next one, but the Magnus effect. But let's say this is the projectile and we're spinning, and you got the air pressure and it hits it, it comes around it, and it just kind of like, and so you also got the lifting factor of the spin, which causes it to go upwards as well. Clavios and Evitos effect. I believe that's the earth rotation effect on the bullet flight. So let's say you're shooting to the west, it's going to go lower 2 or 3 inches roughly. Shooting to the east, it's going to go higher 2 to 3 inches. So you're going to want to shoot north to south or south to north. So that is also because you're on a spinning planet, right? So you're trying to make a straight shot on this quarter to say is Earth, right? You gotta compensate for that. Alright, next one's vertical angles. I'll just use the lighter. A pin. So this is your sight. This is the trajectory. Goes at an arc. To hit that same point, you're using more. It takes farther. It takes more. Shoots off at an angle. Gravity starts taking effect, and it gets pulled back down. Okay, so the last one is transonic ballistic performance. This is when a projectile goes from subsonic to supersonic to subsonic. And as that goes, we got our stabilization in place here, going along, we hit it, you know, it keeps going, and then after it hits supersonic, we're doing just fine, and then we're losing speed as the pressure and gravity and air pressure and everything just is reacting with the projectile at hand, and we're slowing back down, right? We're coming back down towards the target, and we're coming, and we just right back through that sound barrier, right? And then we're just doing one of these wobblies, right? And hopefully that stabilization keeps it going to hit its target without going way off course. Hey!